Welcome to Chapter 5, Thermochemistry. In this chapter, we are going to be looking at energy, how energy is involved in chemical reactions, how it is produced in chemical reactions, how it is consumed in chemical reactions. So we're going to start here with brief discussion on just what exactly is energy. Because I'm sure you've heard the term before, probably thousands of times in your life, but maybe you've never really sat down and thought about what exactly is energy? Well, from a scientific standpoint, we define energy as the capacity to do work. And that then begs the question, well, scientifically speaking, what is work? Well, and according to physics anyway, work is the result of a force acting through a distance. So it's essentially a force moving. It's moving something. That is what work is, and so energy is the capacity to do that. We get our energy from all kinds of different sources. For our own daily use outside of our body, we get energy from burning things like coal, which you can see here. We also burn things like gasoline, which is related to coal, to power our cars and things like that. We ourselves actually are also powered by energy, but we get our energy not from coal or oil. We get our energy from things that were once alive, essentially. So whether that be animal material or plant material, which sugar would be counted among that. Most of the sugar, I believe, that we eat comes from well, a lot of it comes from corn. There's like high fructose corn syrup, which I believe does come from corn, but there's other biological sources that we can get sugar from. So it's things like that that we get our energy sources, where we eat those materials and our body converts those materials into molecules that we can then use to move our arms and legs, have our heart pump blood throughout our body, keep our bodies warm. We use those molecules to provide energy for ourselves. So this is just kind of an interesting side note here. I'm not going to spend a whole lot of time on this, but an interesting side note on where our energy comes from. In reality, almost all of the energy sources that we use, actually you can find a pathway back to the sun for nearly all of those. If you think about any type of either natural gas or oil or coal, any of those fossil fuel type materials, those actually were at one point living things, whether they are plant or animal. Most fossil fuels actually used to be plants. It's kind of a misconception for a lot of people, is that you fill up your car with oil and it's like, oh, this used to be a dinosaur. Probably not. It was probably moss or some other plant-based material. The vast majority of fossil fuels were plants at one point, not dinosaurs or elephants or something like that, or mammoths probably. I don't think you would have elephants in your gas tank. But anyway, those you can actually trace back to the sun, because those things were alive. Number one, because the sun was heating the planet, but more importantly, because plants need sunlight to exist. They eat, so to speak, the sunlight. Not really, but they use the sunlight as part of the process for producing things that keep them alive. And then the animals also eat the plants. And so really all that can be traced back to the sun. Solar energy, obviously, powered by the sun. Wind energy, also powered by the sun, because wind is actually produced from differential pressures from one place on the Earth to another. Those differential pressures are caused by differentials in temperature, and if there was no sun, there would be, like, the Earth would have no differential temperatures. It would just be a cold, dead rock. And so wind is actually solar powered as well. Let's see, what other kinds are there? Hydroelectric power is also another big one. That is also solar powered, because how did the water get behind the dam? Well, the sun heated up the ocean. Water in the ocean evaporated, went into the sky as clouds, rained down on the earth behind the dam, and then the dam was able to take that water that had been put at a higher elevation and use it to create electricity as it flows down to lower elevation. And none of that would have been possible if the sun had not heated up the water and forced it into the atmosphere. So really the only power sources that are not solar powered would be things like geothermal and nuclear. Unless you want to get super technical and be like, oh, well, if the sun hadn't been there, then the Earth wouldn't have formed in the first place. It's like, oh, okay, now that's a step too far, I think. But anyway, just a kind of an interesting little side note there. Moving on to talk about energy here, we can broadly categorize energy into two big sections here, two different parts. You can have kinetic energy, and you can have potential energy. Kinetic energy is energy that is due to something moving. So thermal energy is an example of this, because thermal energy, which is associated with temperature, is due to molecules and atoms rotating, vibrating, and translating to a certain amount, mostly rotation and vibration of molecules and atoms. So right now, if you look at your hand, it doesn't really look like it's moving if you're holding it still. But in reality, all the molecules and atoms in your hand are shaking and vibrating quite a bit, actually, at the molecular level. And that is thermal energy. There's energy associated with that movement. Potential energy, on the other hand, is due to the position or composition of a material. So chemical energy is an example of this, because that is energy associated with the structure of atoms and electrons and nuclei, how things are arranged relative to one another. There's a certain amount of energy associated with those arrangements. Another common example of this is gravitational potential energy. So if you take your hand and you lift it up in the air, you might notice that you can't do it for very long. Eventually you get pretty tired because gravity is trying to pull it down, and it takes energy to hold it up there. You're fighting against gravity trying to pull it down. When your hand is up higher, though, it does have a higher gravitational potential energy. And that's why if you stop trying to hold it up there, your hand drops. Because everything in the universe will spontaneously go from higher to lower energy if it's able to do that. The universe is lazy, as I like to say. Everything wants to go to a lower energy. All right. Just a little bit more here about potential energy, and so here we have that example of gravitational potential energy once again. But here we actually are showing that when you release the ball, in this case, from its high gravitational potential energy state, and it starts to fall, you notice that you actually are changing the type of energy that is at play here, that is being shown. It has a high gravitational potential energy up here, and as it's falling, it's converting that gravitational potential energy into kinetic energy. And we'll talk more about converting energy later on. Just as a little side note here, this molecule, this section right here, is called toluene. Each of these three parts is a nitro group. So we have toluene with 3 nitros. This is trinitrotoluene, or TNT. This is the explosive TNT, which has quite a bit of chemical potential energy, as you could imagine. So a few other different forms of energy here, just briefly to mention these. We're not really going to get into them too much throughout the rest of the chapter. But there is also electrical energy. This is kinetic energy associated with electrons flowing. There's heat and thermal energy, which we will talk about a lot in this chapter. And this is energy associated with molecular motion. Light is also a form of energy. This is kinetic energy associated with energy transitions in atoms. So when electrons move from one area to another area, they give off light as a result of that, and we'll talk about that a good bit in Chapter 6. Nuclear energy is another very, very potent form of energy. This is potential energy that is due to the position of protons and neutrons in the nucleus of an atom. And then we have chemical energy, which is potential energy due to the structure of atoms, the attachment between the atoms positions relative to each other, or the molecule's relative position in the structure. Alright, I think we'll call it there for this video. In the next one, we're going to start focusing on this type of energy right here, heat. So we're going to talk about heat, what we're discussing when we say that we have a certain amount of heat, what that means, and then we'll start jumping into the conservation of energy, how we can move energy from one place to another using heat, and how energy must be conserved. So we'll see you in the next video.